The final problem involves situation calculus. Now, in the domain I want to describe, we have a combination lock with 4 digits. And the correct combination that will open the lock we'll call X. And there are 2 actions you can perform. One is to dial any combination on this dial. And if you dial the correct one, X, then the lock will open. And the other action you can perform is to press a lock button. And if you press that button, then the lock will be locked, whether it was open before or not. Now, I'm going to describe some axioms, and I want you to tell me whether these axioms are correct for the domain or not. First, the possibility axioms. So one choice is the possibility of the axiom that says if C equals X, then it's possible to dial C in situation S. And here I'm assuming that all variables are scoped, so that we say an implicit for all C and for all S here. And X is not a variable. This is a constant referring to the correct combination. The possible axiom is for all C, if C is greater than or equal to 0 and less than or equal to 9999, then it's possible to dial C in any situation S. So tell me which, if any, or both, of these axioms you think correctly encode the situation. Next, we'll look at the possibility axioms for the lock action. Here's one. We can say, if the safe is open in situation S, then it's possible to execute the lock action in S. Or maybe we should say, if the safe is not open in S, then it's possible to execute lock in S. Or maybe we should say, if true, then it's possible to execute the lock action in situation S. And tell me which, if any, of those represents a correct representation of the problem. And finally, we need successor state axioms for all the fluents. But there's really only one fluent, and that's whether or not the safe is open. So here's one example of a successor state axiom. We could say, for any state, for any situation and action, if it's possible to execute that action in the situation, then the open fluent is going to be true in the result of executing that action, if and only if the action is dialing the correct combination X, or if the safe was already open in S and the action is not equal to lock. That's one option. And the other option is the same thing on the left-hand side and on the right-hand side. It's open if and only if the action is dialing the correct combination and the action is not equal to lock. So tell me which, if any, or all of these are accurate representations of the problem. Now, in each case, I want you to tell me if each of these axioms are good as they stand alone. I don't want you to look at any combinations of axioms, but just go through each one and check the box if you think that the axiom on that line alone is a correct representation of the problem.